Question 6 asks us to form an inequality. And sometimes, and in fact every time you do something like this, please draw a diagram, because it can show some working out to it, but also it can just help you visualize what's going on a bit. So here we have a construct of rectangular based house extension, and the length of the extension must be 10 meters greater than the width. So it's rectangular, and the length of the extension must be 10 meters greater than the width, and the width is x. So if that's x, this is going to be 10 more than x, or x plus 10. So it says quite simply, write down an expression for the area of the extension. Well, the area is simply the area of the rectangle. So it's x upon x plus 10. And if you want to expand that out, that's fine. X squared plus 10x. So there's part 1. Part 2 then goes on to say the area of the extension must be less than 375 square meters. Form an inequality, first of all. So we know that the area is less than 375. In other words, x squared plus 10x, the expression we got for the area, must be less than 375. Rearranging that, x squared plus 10x minus 375 is less than 0. Now what we're asked to do is solve this inequality and find the range of possible values for the width of the extension. Now to solve this inequality, the first thing I'm going to do is look at the corresponding quadratic equation. Equals 0. And what I want to do is find two numbers that multiply to give minus 375 and add to give 10. Now it might take a wee bit of thinking there. So we've got x, and I'm thinking it's going to be 25 and 15. And to get a positive 10, we have to have x plus 25 and x minus 15. So when we solve that, we get values of x as 15 or x equals minus 25. And I'm going to call these, instead of solutions to this equation, I'm going to call them the critical values of our inequality, 15 and minus 25. And they're critical values because when I draw the graph of this inequality, I've got a value of minus 25 here and a value of 15 here. And when I draw the graph of y equals x squared plus 10x minus 375, it's a positive quadratic because it's a positive x squared term, and a positive quadratic is a happy face. So when I draw this, it's going to go something like that. Okay? My critical values are the values where my curve crosses the x-axis. Now, that's all very well, but what we're asked to do is find when is this expression, when is that curve less than 0? Well, it's less than 0 when the curve is below the y-axis, or below the x-axis, sorry. In other words, it's less than 0 whenever we are between the values of minus 25 and 15. So in this region here, those values of x, the curve is below the x-axis. It is less than 0. And so my values of x are between minus 25 and 15. Now be careful. We were told that it must be less than 375. It's not less than or equal, it's strictly less than. And so our inequalities will be strictly less than as well. Won't have an equals part to it. The last thing is, we look at our answer here and we say, is this a sensible answer? Does minus 25 to 15 make sense? And we've got to think, well, what does x stand for? Well, x is the width of the extension. And in this case, we're thinking, well, x can't be a negative number. Okay, it can't be negative. So instead of minus 25, we're going to have 0 less than x, which is less than 15. It can't be a negative number. I'm not going to put it equal to 0 because there's no point having the width of the extension being 0 meters. So I'm going to again have less than symbols here. And now we have an inequality. We've solved the inequality, and we've also used our common sense to get our final answer.